This is a lesson for Chapter 2, Section 1. Let's take a look at our first problem. It talks about a group of students are washing cars. They spend $15 on soap. So let's highlight some important information here. And the $15, spending $15 means that we are going to take away $15 from the total. But then they also have this word charge of $10 for each hour. So let's highlight the important information here. So we're going to spend $15, and so the spending $15 is where the minus 15 comes into play. And then it says he also has a charge of $10 for each car. Well, for each car means that if it's 2 cars, it's going to be $20. 3 cars, it's $30. And so that's the variable amount. And so we don't know how many cars we're going to have, but we do know that we're going to multiply that number of cars by 10. So if we look at the equation that they gave us, which is all the way over here, the 10 times x is where the part comes into play where we are multiplying the $10 for each car. And so y represents the total cost. And so what we want to do is we want to find out, are these ordered pairs solutions of the equation? That means, do they actually make sense? And so what we're going to do is we're going to take our x value, which is 5, and our y value of 35, and substitute them into the equation that we're given. So let me rewrite the equation here. Y equals 10x minus 15. So spending $15 on the soap and $10 for each car, that gives us our total amount that we were going to make. So they say 5 represents x. So that would mean we had 5 cars. So 5 times by 10, and then take away 15, they're saying should equal $35. Let's see if it does. So if we go ahead and do that work, we're going to make $50 from those 5 cars. We're going to take away the $15 for the soap that we ended up buying. And sure enough, that gives us $35. So yes, that means that this point is a solution of the equation. We'll say the ordered pair is a solution of the equation. Well, let's take a look at the next one. So it's very similar, just different numbers. So again, the first number is always your x value, the second number is your y value. So we're just going to substitute it into the equation. Y equals 10x minus 15. So if I go ahead and do that work, in place of y, I'm going to end up putting the 195, because that's what they're saying. That's how much money they're saying we'll get after 20 cars. So let's see if it's the case. So 20 cars went in for x. We multiply that by $10 per car. That gives us $200 is the amount of money that we're going to end up making from those 20 cars. But we're going to take away the $15 for the soap that we ended up buying. And we go ahead and do that subtraction. We end up with 185. Well, that doesn't equal 195. So since those don't equal, we'd say no. The ordered pair is not a solution of that equation. Well, let's take a look at the next one. Again, the first number is always x, second number is y. So we're going to say that $485 is the amount that we'll make after we wash 50 cars, it says. So x was 50 cars. And then after we do that, we make all that money from those 50 cars, then we've still got to pay that $15 for the soap. So 10 times 50 gives me 500 minus 15. So we're seeing if that equals 485. So we go ahead and do that same work. We have 500 minus 15 is 485. And sure enough, since those two numbers are equal, we would say yes, the ordered pair is a solution. Now let's take a look at the next type of problem we'll see. So the next one talks about how the temperature Y in Albany is 6 degrees colder than the temperature X in New York. So 6 degrees colder than the temperature X in New York is Albany. So Y equals temperature in New York, and then minus 6 degrees equals Albany's. So that's the equation they give us. They give us this chart, and we're just supposed to plug in the numbers. So they said, well, let's say the temperature X, which is the temperature in New York City, is 56 degrees. Find the temperature of Albany, Y. Well, all we're going to do is substitute 56 in for X. Do the subtraction and come up with our number, 50. And that represents an ordered pair, 56, 50. Put parentheses around it to show it's an ordered pair. And we do that with the next one. So if it was 48 degrees in New York City, take away 6 degrees, and that would end up giving us 42 degrees. So we'd write the ordered pair, 48, 42. Same thing if it was 44. 44 degrees in New York City, take away 6 degrees to find the temperature in Albany, New York, which would be 38. So 44, 38. And the last one, 41 degrees, and take away the 6 degrees to find out the temperature in Albany, which would be 35. So 41, 35. Well, same sort of thing on this one, just a little bit more involved. So it says Nate scored X number of 2-point baskets. So X number of 2-point baskets, that's this part right here. X number of 2-point baskets. And Y number of 1-point free throws. 1-point free throws. Well, he ended up scoring 18 points altogether. So this is like the total right here. And so if I take the amount of 2-point baskets away, times the number of points as well, away from Y, or from the total, that'll give us Y, which is the number of 1-point baskets. So all they're doing is saying they're giving you the value of X, you're going to put it in place of X. And so 18 minus 2 times 3, so the 2 right next to the 3 means multiply. So 18 minus 6, and that gives us 12. And so from there, we go ahead and write the ordered pair, 3, 12. And do the same thing with the next one. So we have 18 minus 2 times by 4. So 18 minus 8 gives us our answer there for Y, which is 10. So then we'd write the ordered pair. It would be 4, 10. And the next one, 18 minus 2 times by 5. So 18 minus 10 gives me 8. And I write the ordered pair, which would be 5, 8. And the last one there, if I had 18 minus 2 times by 10, and we'll see what this one is. This one's going to give us a different number. 18 minus, and then 20. That gives us a negative number. That gives us negative 2. So that ordered pair would be 10, negative 2. Well, the thing about this one is that Y is supposed to be the number of 1-point free throws. Well, you can't have a negative number, we'll say, number of free throws. So this one kind of doesn't really even make sense. So that is just a understanding the problem type of question there. And let's take a look at the last set of problems. And so the last one looks like this. Ed has $21 and plans to spend $2 each day. So let's see what it is. This is a total. So let's start with that. $21, and he plans to spend $2 each day. So let's do this. Let's write a variable for that. Let's let X equal the number of days. And so if he's going to spend $2 each day, that means minus 2. So spends, we'll put in that minus sign there, 2 times X. So we're supposed to write a variable in an equation in 2 variables to show how much he'll have after D days. Oh, they actually give us the variable we're supposed to use. So instead of X, let's go ahead and change that to a D. So we've got after, let D equal the number of days. So we'll do 2D equals, or 21 minus 2D. And we're going to set this equal to another variable. Let's call the next variable M. M stands for money left over. So we're going to say M, the money left over, equals the amount that we started minus 2 times each day. Well, then they say, how much will Ed have after 5 days? So after 5 days, we're going to multiply that by 2, And then we're going to take that answer away from 21. That's going to give us the money we have left over. So the money we have left over equals 21 minus 10. So we continue on there. Money left over equals 21 minus 10 gives us 11. So $11 is the amount of money that we'd have left over. So these are examples of what you're going to see on tonight's homework. Good luck.